Hey everyone, and welcome to your C++ tutorial on classes. So, to get started, I'm going to get rid of this hello world instruction here. I'm going to create a comment, and let's just quickly define what a class is. So, you can think of a class as a code template or blueprint for creating objects. The class of an object defines, starting a new line here, the type of the object. So a class is a sort of a blueprint for creating objects. And so a class basically creates the types. When you create a class, you're creating a type. So I think it'd be good to also define what an object is. So an object is a block of memory set aside and configured according to the class blueprint, right? So this is important, right, to understand the difference between a class and an object. A class is the blueprint for an object. So you can kind of think of it like you're building a car, for example. In order to build a car, you need a blueprint for how to build that car and what components go into that car, right? It has tires, it has, a steering wheel, it has a frame, it has windows, and it has an engine, right? And so you need all of these components and a blueprint for how all these components kind of fit together and how the functionality behind all of these components. Another thing that's important is that in the analogy of a car, with one blueprint, you can build many cars, right? So you have one blueprint, but you can build many instances or different objects, right? So if you have one class, you can build many objects from that one class. So that class to object relationship is a one-to-many relationship. Okay, so let's look at the C++ syntax behind how to create a class. So I'm going to create my class above my main function because, as you remember in our previous tutorial on functions, when you define something new, you can't access it in the main function if it's declared below it, right? You need to declare it above the main function, and classes are the exact same. So to start off a class, I'm going to use the keyword class, and then I'm going to give it a human readable name, and we'll call this car, right? And so after I have our class name, I'm going to create open and closed curly braces, and this defines the scope of the class, right? So it starts here, ends here, and we finish our class declaration with a semicolon. So there you go. This is how you create a very basic empty class. So now let's see it used in our main function here. So here we have our empty class. So there's really nothing in this class. Let's create an object from it. So to create a car object, all we do is we use our car type, right? Because remember, a class, when you create a class, you're really creating a type. And so we're using this in the same way that we would create an integer called age. We can also create a car object called Camry, right? So this is the same, these are sort of parallel here. So we have our type and our human readable name. That same way we have our type, it's car, and our human readable name of the object, right? So our object's name is Camry now. Awesome. So we can see here how the class has created a type, right? This is our car class and our car type. Now from that type, we've created an object. So we can create multiple different types of objects, right? I'm not a car guy, so I don't know the different types of cars here, right? But we have our 3 different objects here, and they all share the same type. So you can kind of see this this one to many relationship happening here, right? And so each instance of our car has a different human readable name, and they all get their own separate memory where they keep anything that's in our class. Right now, there's nothing in our class, so let's change that. So the whole point of classes really is to be able to group sort of data and behavior, right? And we're going to get into that more in next week's tutorial on encapsulation, right? So we're going to be talking about a lot of core concepts to classes in next week, actually, in the encapsulation tutorials. For this specific tutorial, I kind of just wanted to talk about how to create a class, how to use a class, and we'll just go over an example with like one or two member variables. So inside of our car class, everything is private by default. And what private means is that if I was to create an integer called miles, right? Let's say this is the number of miles driven, that the car has been driven. This member variable I can't access outside of our scope here. However, if I use our public keyword, now I can access this miles variable in every instance of our class down here. So what we can do is every instance is going to have a miles variable. And right now, what I'm going to do is I'm going to set this equal to 200 really quick. So our car has been driven 200 miles. So what I'm going to do is I'm going to print out our, so we'll say Camry miles driven, and we are going to print out the Camry.miles variable. We're going to create an end line here. What I'm going to do is I'm just going to copy this for each car here. Corolla, Intrepid, and we're going to say Corolla.miles and Intrepid.miles. So here we have our class, and we have a public member variable, right? So what we've done here is we've created a variable inside of our class. This is called a member variable. Every time we instantiate a new object of the class, each one gets its own miles, right? So each one of these objects has a member variable called miles, and it's equal to 200. So let's run this really quick. We'll use our G++ compiler to compile our test, and we get a warning here, which says that we're doing in-class initialization. So in C++, you generally don't want to do this, but I'm just doing it for the sake of explanation. In our video next week on encapsulation, we're going to go over methods and constructors inside of our class, right? But for now, we're just going to do it like this. This is good for learning, but I really wouldn't do this in any type of production code. But it will compile. So we've compiled our code here, and I'm going to run our executable. And here we have Camry miles driven is 200, Corolla miles driven. Oh, it says driver. Sorry, I meant to say driven. And Intrepid miles driven is 200. So they're all the same, right? Because I'm just going to correct that really quick. So whenever we create a new instance of the class, each one gets its own copy of miles. So now what I'd like to do is show you how this member variable can change. So to do that, we are going to take our Camry object. We're going to access miles. And since miles is just an integer variable, once we have it accessed here, we can treat it just like any other integer variable, and we can set it to 300. For our Corolla, let's set the miles variable to 1,000. And for our Intrepid instance, let's set miles equal to 500. So now let's run our program again. Let's use our G++ compiler and run it. And we can run our executable. So as you can see, we have each instance of the car class contains a different value for its miles variable. So you can see they all start off the same because we've assigned it in the car class, but we change them throughout the running of the program, and they all have different values. And this goes to show how a blueprint can create an object, but that object can mutate through the running of our program. So just to recap really quick, a class is a code template or blueprint for creating objects. When you create a class, you're creating the type of an object. An object is a block of memory set aside configured according to that blueprint. So this is how you define a class. Use the class keyword and you give it a human readable name. By default in a class, variables that you declare in a class are private, so you need to use the public keyword to make them public. And so each one of these classes has a member variable of 200, and this is you can think of this as the state of the object. When it's declared this way, each object we create will have the same state. They'll start off with the same state, which is in miles of 200. But through the running of our program, we can mutate that state, right? So each instance has a separate state, even though they're all defined from the same object. And each state can be mutated throughout the running of our program, and we will learn in our following weeks how we can add how we can start off each object with a different state using constructors and parameters and constructors, and how we can add behavior to our classes. But right now, what I just like to focus on is this one-to-many relationship between classes and objects, how classes can hold state, and how that state can mutate throughout the running of the program. So I hope you guys learned something in this tutorial. Thanks.